Today we are exploring Advent of Code 2023, Day 14, Parabolic Reflector Dish. I'm going to show you 80 lines of code which solve it in 1 second. Let's dive in. We are given a platform of rounded rocks, O, cube-shaped rocks, hashmark, and empty spaces, dot. By tilting the lever, all rocks will slide north as far as they will go. Cube-shaped rocks and edges of the platform stop the rock slide. We must calculate the total load on the north support beams after tilting north. The amount of load caused by a single rounded rock is equal to the number of rows from the rock to the south edge of the platform, including the row the rock is on. Cube-shaped rocks don't contribute to load. First, I read the input line by line into a 2D array. Then I tilt the platform to the north. If I'm in an empty space, I increment the slide counter dy. If I'm at the cube-shaped rock, I reset the counter, because it blocks other rocks from sliding. Finally, if I'm at the rounded rock, I slide the rock by dy. Then I just simply calculate and print the load of rounded rocks. The twist for the second part is that we must find the total load on the north support beams after 1 trillion cycles. Each cycle tilts the platform 4 times so that the rounded rocks roll north, then west, then south, then east. After each tilt, the rounded rocks roll as far as they can before the platform tilts in the next direction. I wrote tilt functions in all directions. The algorithm is straightforward. I simply simulate the platform cycles until the state of the platform starts to repeat. Then I calculate the length of the repetition and the position of the first repetition. Then I can calculate in which state the platform would be after 1 trillion cycles. That's all I have for you today. If you found a more efficient solution or have any questions or comments about this, please put them below. If you like this video and would like to see more like it, please subscribe. Thank you.